Hello, this week I'm talking about camera movement. In a first-person shooter, the center of the camera is somewhere above the screen, roughly representing your head. This doesn't work as well in a city builder. You want the center to stay on the landscape, so instead of moving your head, you are moving a map in front of you. For this purpose, I have a little ball moving over the landscape and the camera attached to it by a pole. To rotate the camera, we rotate the ball and the camera spins around a focal point in the landscape. I wanted the ball and the camera to go up and down with the hills. At first I tried using Unreal's physics simulation, so it would fall onto the surface because of gravity. Camera just rolled down the hill. Instead I ended up drawing a vertical line onto the ball and getting the height of the first thing the line hit, then moving my focus point there. There were still some glitches that only went away when I asked Unreal not to worry about camera clipping through things. For zooming, I wanted the camera to look at the map from above when far away and change its angle as it got closer, as if you were looking at the landscape from a nearby hill. We have two positions we want the camera to move between when the player moves the mouse scroll wheel. How do we find the halfway point between these two positions? We take half the value from the starting point, half the value from the end point, and add them together. In fact, to find the value a third of the way along, we take 2/3 from the starting point and a third from the end point. Traditionally, we use a value t, which goes from 0 to 1, to mark how much of the end point to use. We then add the t times the end point to 1 minus t times the starting point. Here I'll mark 1 minus t with the symbol r. Just remember that t plus r equals 1 because r is defined as the remainder needed for t to reach 1. So at the beginning, when t is 0, we remove the endpoint from the sum because anything times 0 is 0. And what we are left with is just the starting point. And when t is 1, we are left with only the endpoint. So now when user rolls the scroll wheel, we nudge the t value accordingly. Then use the t plus r formula to get the new camera angle and distance. This way we can move smoothly back and forth between the start and end points. Yet it still doesn't feel quite right. Instead of going between start and end in a straight line, I want the camera to descend first and only when it gets close to the landscape start changing its angle. There are several ways to accomplish this. Here's one I find interesting. Let's say you have a 3x3 grid of points. At each point you can move down or right, no backwards movements. How many different routes are there to get from the start point to the end point? Or you have 2 teal and 2 red tokens. How many different ways can you arrange these in a line? Same colors are indistinguishable, so swapping 2 teal tokens does not produce a new arrangement. First, let's examine this point. We can reach it by going right first, then all the way down, turning right at the second step, or going all the way down first and only at the end turning right. Same thing when you have 3 tokens and one of them is red. That red token can only occupy one of the 3 positions. So there's 3 ways to get to this point. By the same method, there's 3 routes to get to this point. The one down movement must take one of these 3 places. So there's a total of 6 ways to reach the end point from the start. It's one of these 3 followed by a right, or one of these 3 followed by a down movement. If, let's say, we moved down from this point, we would end up in a different position. There's only one more route to this position, going all the way down first and only turning right at the end. If one of the tokens is a different color, there's as many variants as there are tokens. If they are all one color, there's only one way of arranging them. This particular arrangement of numbers is called Pascal's Triangle. Each row is made by adding up elements from the row above flanked by 1s. It's useful for combinatorial tricks like this. So now let's multiply t plus r by itself 4 times. We take one element from each of the 4 bracketed terms. How many ways can we take 2 t's and 2 r's? 6. There's only 6 ways of arranging them. T times t is t squared, so we have 6 total t squared times r squared. There's 4 ways we can get t cubed times r, same for r cubed times t. There's only one way to take all 4 t's and only one for all r's. That's all the possible combinations. If we add them all together, we get t plus r to the power of 4, which is 1. Remember, t plus r is 1. 1 times 1 times 1 times 1 is still 1. So why do this? Well, we multiply this t to the power of 4 by our endpoint. When t is 1, r is 0, so all of these terms disappear because anything times 0 is 0. 1 times endpoint is just the endpoint itself. Just like with t plus r, we have a way to go from a starting point to the end point by moving t from 0 to 1, except that we have these 3 extra terms. We can multiply them by midpoint values to influence the route we take between the start and end point. Now, when the player rolls the middle mouse button, the camera gets closer until the very end, where it starts flattening out the angle instead. If you want more midpoints, just take a row of the Pascals triangle, times each element by t and r, have t powers descending while the r powers are going up. Or just use interpolation tools someone else built for you. Most of the time that's the safer option. It's still good to know how these tools work underneath. That's all for this one. Bye.